All right, so in this lesson we are going to solve, let me change colors. We are going to solve word problems. We're going to solve word problems using a system of equations. So, system of equations. All right, so situation one. Hannah and Miracle are collecting pictures of Mr. Lopez. Hannah already has 10 pictures and collects one more every 3 days. Miracle only has 1, but collects 5 every 6 days. When will they both have the same amount of pictures? So we're talking about Hannah and Miracle's pictures, right? That's ultimately what we're concerned about. Hannah and Miracle's pictures, because we want to know when they're going to be the same. All right, so Hannah, let's make Hannah green. So Hannah has 10 pictures, and then she collects 1 more every 3 days. Okay, what color do we want to make Miracle? Let's figure this. So Miracle has 1 picture, but collects 5 every 6 days. And then it wants to know when they will have the same amount of pictures and how many pictures that will be. So ultimately, we're talking about the pictures for Hannah and the pictures for Miracle. We're talking about the pictures for Hannah, and we're talking about the pictures that Miracle has. All right, so Hannah has 10 pictures. And the number of pictures increases because she collects more. So she collects about 1 every 3 days. Or on average, 1/3 of a picture, 1/3 of a picture every day. Miracle, on the other hand, only has 1. But her collection grows by 5 pictures every 6 days. Or an average of 5/6 of a picture every day. Let's go ahead and graph these 2 relationships. So the y-axis, is whatever you want to call it. It's the number of pictures that each of them has. I hesitate to say y-axis because really this is now the pictures axis, right? And this is the number of days. So maybe I should put pics and days. So we start at 0, 1, 2, 1, 2, and to help me out, 5, 10, and then this one's 5, and this one's 10. Okay, so let's start with the number of pictures Hannah. So Hannah starts with 10, and her picture collection grows about 1 every 3 days. Okay. And it can keep going. I don't know whether they're actually going to share the same amount of pictures and days. We'll find out. So this is Hannah's pics. And I could probably draw that a little better. It looks just like a bunch of Dumbo. Hannah's pictures. It looks like Hannah's pies. Pics. Okay. And let's represent Miracle's pictures and days. So Miracle starts off with 1 picture, and her collection grows 5. 1, 2, 3, 4, 5 every 6 days. 1, 2, 3, 4, 5 every 6 days. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Ooh. Kind of lucky because that is where it's supposed to intersect, right? And I didn't even draw the other one there. Okay. So it's important. This shows you it's important. You may as well graph like not quite a few, but enough so that you don't make the same mistake I did. Okay, and this is where they intersect right here. See, up 1/3, and then up 1, 2, 3, 4, 5/6. Yeah. So my solution is 10, 11, 12, 13. I should write that there. That's 13 days and 16 pictures. So 13 days, 16 pictures. All right, cool. So let's answer the question. The questions. When will they have the same amount of pictures? How many will they both have? So Hannah, that looks like Hannah and Miracle will both have 16 pictures. At 13 days. And remember, because I like at 14, 15, 16, they both have different ones. So before 13 days, they have different amounts of pictures. And then after 13 days, they have different amount of pictures. It's right at 13 days that they both have 16 pictures. If it helps you, instead of writing it like this, you can also say at 13 days, Hannah and Miracle will both have 16 pictures, if that's easier for you. So let's go to the next one. All right, so situation 2. We start off with Michael. So Michael has a bag of 16 candies. There's a hole in it, and he loses about 1 candy every 2 hours. His brother, on the other hand, only has 7 candies, so he has less candies. But his brother gains about 2 every 5 hours. He gains 2 every 5 hours. All right. So the questions are: after how much time will they both have the same amount of candy? And how much candy will that be? So let's talk about Michael. So ultimately, we're talking about the candy. So the candy for Michael. The candy for Michael starts with 16 candies. So the amount of candy that he has starts off with 16, but he loses. So it decreases by 1 candy every 2 hours. You can also think about this as he has 16 candies, and he loses about half a candy every hour. His brother, on the other hand, so the candy for his brother starts with 7 candies. So his brother originally has 7 candies, but he gains. So the amount of candies increase by 2 candies every 5 hours. Or you can think about this as 2/5 of a candy every hour. So when will they both have the same amount of candy? How much will that be? Let's label our axes. So this will be our candy axis, and this will be our hour axis. You can always put time also if you prefer. Just make sure you put, like if you were to use time, just put in parentheses like hours, so I know that you're talking about hours. Ooh, why is it so hard for me to write H's? Hours. Okay. And 0, 1, 2, 0, 1, 2. This will help me out later. Potentially. So Michael starts with 16. So 5, 10, 15, 16. And it decreases by 1 every 2 hours. So decrease by 1 every 2 hours. 1 every 2 hours, 1 every 2 hours. I'm going to keep doing this because last time I didn't go far enough. Okay, better. Okay, so let's see what we can do as far as this. Okay. Well, that's supposed to be there. But this is Michael's candy. Yeah, Michael's candy. Now I can make that a little better. Michael's candy. All right, so let's represent his brother's candy. So his brother was in P. Okay, so his brother starts off with 7, 5, 6, 7. But he actually increases by 2 candies every 5 hours. 2 every 5. Oh, right here. So we can already tell that's where they're going to intersect. And this represents... Oh, this is a different red, but actually let me, just for the people with the notes, I think it's important that I use the same color. And then I'll do it one more time. So, ooh, so close. So close again. Okay, cool. And this will represent brother's candy. Brother's candy. So, they intersect, or the amount of candy is the same right here at 10, 11. So 10, 11. So in conclusion, Michael and his brother, Michael and brother, I guess we should put his brother, Michael and his brother. I'm going to write it. You know how I wrote this one as in the 16 first and then the 13? I'm going to write this one 10 first, actually. So, because some of you might prefer it. So, at 10 hours, Michael and his brother will both have 11 candies. Yeah, so at 10 hours, Michael and his brother will both have 11 candies. I can write 11 a little better. It's so like writing these without making them seem like mistakes or like something else. So we'll both have 11 candies. That's good enough. Thank you.